So welcome everybody to this latest video on 162 Maths, and in this video we'll be focusing on AQA A2 Algebra and introducing partial fractions. So when people think of partial fractions, they're thinking, what on earth is that? So let me break it down to you literally. So partial fractions, so this is when you break down an algebraic fraction into smaller fractions. Now when working at a low level, probably higher GCSE or maybe AS level, you're probably doing the opposite to what we will be doing now. So for example, here we've got a typical algebraic question. So here what we've been asked to do is to simplify these two smaller fractions that have been written algebraically. So what we want to do first, if I just do this over here, we're going to multiply the first fraction by this denominator and the second fraction by this denominator, so we have common denominators, so we can merge the two things together, because again we are adding these two fractions together. So then what we do then, so if I multiply the first, so if I just write down the first fraction, and what we're going to do is we're going to multiply that first fraction by the denominator in the second fraction. So we're going to multiply the top by x plus 1 and the bottom by x plus 1. And then with the second fraction, so let's just write down the second fraction. So we've got 3 over x plus 1. And just note that I'm putting the algebraic linear function in brackets. And here I'm going to multiply this second fraction by the first denominator. That's going to be x minus 5 and x minus 5. And so now I've got a common denominator. What I can now do is simply join those two things together. So what I've got is I've got 2x plus 1 plus 3x minus 5. And that's all. Now because I've got a common denominator, I can just write it as x plus 1 and x minus 5. Now from this, typically what you would then do is you then go on to expand the numerator. Obviously you leave the denominator in brackets. Try not to get into the comfort of expanding everything. So I know obviously teachers always say when you see brackets, expand them, but in this case you only expand the numerator. So what I've got is I've got 2x plus 2 plus 3x minus 15, and that's all over x plus 1 x minus 5. And then I can simplify the numerator. So I've got 2x plus 3x, which is 5x. I've got 2 minus 15, which is minus 13. And that's all over x plus 1 x minus 5. What I would then do is see, can I factorize the numerator, which in this case I can't. So this would be my final answer. Now in this particular a topic of A2 Maths, what we're doing is we're going to start with this, and what we want to end up with is this, and that is our end game. So not to go all Avengers on you, this is basically what the question is going to be, and this is what our answer is going to look like. Now a very common yet a very annoying question I get asked as a maths teacher is why do we need to learn this, why do we need to do it? Now, the main purpose of breaking an algebraic fraction into smaller fractions is so that it's easier to differentiate and integrate. Now, depending on what where you are in your syllabus of A2 Maths, it does get a lot more complicated. So this topic is like the part A, part B of a question, and then part C or part D will be then lead on to binomial expansion or differentiation or integration. So it's a really an important aspect, particularly when you're starting a really complex question or a high level question, because it is a question that is heavily linked with other topics in the core side of maths. Now there are 4 types of algebraic fractions that look very, very similar, but to break into partial fractions requires slight change in methodology to break up. Now these types are, so the first type is when you've got a denominator with 2 distinct linear functions. The second one is where you've got a denominator with 3 distinct linear functions. The third one is when you've got a denominator with a repeated factor. And the fourth one is an improper fraction, or where the degree of x is the same on both the numerator and the denominator. Now that may sound ridiculously confusing and very, very similar. So again, let me just kind of explain what we're looking at. So 2 distinct linear functions basically means, and again, do not take my official word for this, but this is generally what it usually is where you've got 2 brackets in the denominator. And for step 2, so the denominator has 3 distinct functions. This is basically where you've got 3 brackets in the denominator. Now the key thing is, although this will never really be written in a question, but the brackets need to be different in both of these 2 situations. Now the third one is basically where one of the brackets has a power. Commonly at this level it's only going to be 2, it might be 3 at worst case scenario, but again one of the brackets will have a power. And the fourth one, where it says an improper fraction, or where the degree of x is the same on both the numerator and the denominator, well that basically means when the power of x is higher on the numerator than the denominator, or when it's the same. Now in terms of degree of x, that basically just means the power of x. So here if I had x to the power 4, the degree of x is the degree of x equals 4. If I had x to the power of minus 3, then the degree of x equals minus 3. So that's what we're talking about here. Now again, the best way to understand these 4 types of fractions is to basically link them to examples, which is what we're going to do now. So again, this is one of the most important steps before you even attempt to work with partial fractions, is establish what type of fraction it is. So looking at these particular questions here, so let's get this and call a pen. So this first one, let's call it #1. So this is an example of where you've got 2 distinct linear functions. And if we look at the second example here, so you can see we've got 3 brackets. So this is an example where you've got 3 distinct linear functions. And then looking at this third example here, you can see we've got a power. So this is where we've got a repeated function. And with number 4, example 4, so we've got 2. So here the degree of x at the top, so degree of x in the numerator, in this case is 2, and the degree of x, if I expand that out, I expanded those brackets out, of the denom is 2. So you can see how they are both the same. Now looking at this next one here, you can see that this is what we have classed. So let's highlight what we're actually looking at, because you can't actually see me pointing. So this fraction here, this is what's classed as a improper fraction. And again, the reason why it's an improper fraction is because the degree of x on the numerator is bigger than the degree of x on the denominator. So if I expand these 2 brackets, I'll end up with an x squared, but I've got x to the power 4 at the top, but x to the power 2 at the bottom, so therefore making it an improper fraction. Now, as this is a really important stage, I'm not going to go through how to actually solve each of these 4 things. I'm going to do a separate video on each of these types of fractions for you to watch. 1, to make it easier, quicker, but 2, I can go into detail of the explanation without worrying about going over 3 hours, which nobody's going to watch.